Think about what you've done today. From streaming your favorite show, to ordering food, to that video call you just wrapped up, you are constantly living inside this invisible web of connections. You rely on it every single moment of your digital life. But have you ever just stopped and wondered what's actually happening behind the screen? Well, let's pull back the curtain and demystify the networks that power our entire world.
I mean, right this very second, you're using a network to watch this. It feels like magic, right? Things just appear. But it's all built on a set of brilliant core ideas. So what exactly is this thing we call a network? Let's get a really solid definition down first.
At its heart, it's actually this simple. A network is really just a group of devices. Could be your phone, your laptop, a massive server that are all connected so they can talk to each other and share stuff. Share data and resources. Think about your home Wi-Fi or even the massive global internet itself. That's a network.
And the impact, it's staggering. Modern life literally depends on these networks. They've completely reshaped how we do business, how we learn, how we entertain ourselves. Losing that connection isn't just an inconvenience anymore. For a lot of us, it's a major, major disruption. And that's why understanding them is so important. They're a fundamental part of our world now.
Okay, so to understand how this whole global thing works, let's start small, like really small, right in your own home or office. We're going to begin with the network you probably use every single day, the local area network, or as you've probably heard it called, the LAN.
Your LAN is kind of like your own personal digital bubble. It's what connects all the devices that are physically close to each other, like everything in your house or in one office building. It uses those technologies we all know, like Wi-Fi or that physical Ethernet cable you plug in, to let your computer, your printer, and your smart TV all have a conversation. But for them to talk without getting confused, every single device needs its own unique name.
And that unique name? It's called a MAC address. The best way to think about it is like a permanent fingerprint for your device, or maybe a name tag. It's a totally unique code that's burned right into the hardware. And it's how your Wi-Fi router knows, okay, send that cat video to the phone, not to the printer.
All right, so all your devices are talking nicely to each other inside your home's LAN. That's great, but how do you send an email to someone on the other side of the country? For that, we need to zoom out, way out, and look at the bigger picture, the Wide Area Network, or WAN. A WAN is pretty much what it sounds like. It covers a wide area. Its main job isn't to connect your individual phone to your individual laptop. Nope. Its job is to connect entire networks to each other. It's the superhighway that links your home LAN in one city to a company's LAN in another city, or even across entire continents. So how do you get from your quiet little neighborhood street onto that massive superhighway? Well, you use a router, which is sometimes also called a gateway. Your router, that little box with the blinking lights, is basically the traffic cop for your home network. It stands at the exit of your LAN and directs all the traffic, making sure your requests get out into the wider world and, just as important, that the replies find their way back to the exact right device. So let's just put it side by side to make it super clear. It really all comes down to scale and purpose. A LAN is small, it's private, it connects devices in just one building using simple tech like Wi-Fi. A WAN, on the other hand, is vast and public, using really complex, heavy-duty technology to connect all those smaller networks all across the globe.
Okay, so just think about this for a second. We have billions of devices on millions of different networks, all trying to talk to each other at the same time. How does this not just descend into pure absolute chaos? Well, it's because everything, and I mean everything, follows a very strict set of rules. And the best way to understand these rules is to think of them as the internet's very own global postal service. And hey, this isn't just a metaphor I'm making up. This quote from our source material explains the core idea perfectly. The protocol that basically runs the internet, called TCP/IP, was literally designed with the post office in mind. Data gets packed up, it gets an address, it's sent on its way through a super complex system of mail carriers, and we even get a confirmation when it arrives safely. It's brilliant. So let's walk through it. First up, whatever you're sending, an email, a picture, anything, it gets broken down into these small, manageable pieces called packets. Think of them as individual envelopes. Second, each one of those packets gets a destination IP address. That's just like the street address for a house on the internet. Third, routers act like mail sorters all over the world, guiding each packet along the most efficient path to where it's going. And finally, that TCP part of the name, that acts as your delivery confirmation. It makes sure all the packets actually arrived and then puts them all back together in the right order. Amazing, right? Now, this system didn't just appear out of thin air. It evolved over time. It started with things like the telegraph, which sent simple coded messages over wires.
Then came ARPANET, which was this military precursor to the internet that really pioneered this whole idea of packet switching. And then, finally, in 1989, the World Wide Web was created, which, fun fact, is not the internet itself, but the user-friendly application that finally let everyday people like you and me actually use it.
All right, so with these foundational rules of the road in place, we've built this absolutely incredible modern world on top of them. So let's look at a few of the key ideas that define our connected lives today. From the cloud and smart gadgets to the security that's trying to hold the whole thing together.
We hear the term the cloud constantly, but what is it really? Well, simply put, the cloud is just large-scale virtualization. All that really means is that you're accessing software and storage that's running on some other powerful computer somewhere else in the world. You can use it from anywhere, at any time, without ever needing to know or even care where that physical computer actually is.
And we're not just connecting computers anymore, not by a long shot. The Internet of Things, or IoT, is all about connecting everyday physical objects to the network. Your smartwatch, your smart thermostat, your video doorbell, they are all part of this massive and rapidly growing web of tiny, data-collecting devices.
But, and this is a big but, this explosion of connected gadgets comes with a major trade-off. On the one hand, yeah, we get incredible convenience, automation, remote control, all this valuable data. But on the other hand, a lot of these consumer-grade devices have notoriously weak security, which makes them, and by extension our entire home networks, incredibly vulnerable to attack. And that brings us to a really crucial point about our modern world. Network security is not a one-time fix. It's not something you set and forget. It is a constant, ongoing process of adding safeguards and then checking them over and over again to see if they're still working. It's a perpetual cat and mouse game.
So, wow. We've gone on an incredible journey here, from the simple conversation between a few devices in your living room to the global postal service that runs the internet, all the way to a future that's filled with smart everything. It's really a testament to human ingenuity, but it also leaves us with a pretty critical question.
Think about it. Every new device we add to the network, every little piece of our lives we decide to digitize, it adds another layer of complexity and another potential weak spot. The benefits are amazing. They're undeniable. But as we race to connect literally everything, are we stopping to think hard enough about the consequences? Are we building a network that is not just powerful, but also resilient and secure?